Good morning, everybody. Myself, Appanaji Ratnottam. Today, let's discuss about Nando Tetris Project 1. Nando Tetris Introduction. This is an application to build an operating system using small chips and circuits. In this course, it has been said a computer called hack can be built. A complete operating system can be built with just dragging and dropping components inside a motherboard or in a chips or circuits and not by writing millions of code. The hack computer. After building a hack computer, it can be connected to the keyboard and the display unit and it can execute programs. Hack computer will have basic components as we have in a normal computer, CPU, RAM and ROM. There is a thing called abstraction. Abstraction in programs, we want to know how those things can be executed and worked, but how what is being worked is called as abstraction. In the computer, there are two layers of abstraction. One is a hardware platform and another is a software level. Hardware platform is the basic and basement of all computers and all operating systems. This will contain the digital design, computer architectures, CPU, RAM, chipsets, different complex and elementary logic gates. Software level is the top of hardware hardware platform. It will contain high-level language programs, compilers, translators, assemblers, and etc. So, in this way, there is a software hierarchy upon hardware platform. And when we get a thought, we write a program. We want to execute that through high-level languages. It is been compiled through a compiler, and then there is a thing called VM translator. It will turn the high-level language code into a machine language code, and using an assembler, machine language code can be uh, passed through computer architecture and the operations can be done through CPU, RAM, chipsets, and etc. And this can be done using combinational logics, sequential logics, and it is a part of electrical engineering. But on the top, we are going to do about only about computer science engineering. And every logic gate can be made with just NAND gate, and hence it is called as the universal gate. Now, the steps to install Nando Tetris application. First of all, we should go to Nando Tetris website, and after going here, we see a software icon, software menu here, and then in the software menu, we'll have different options here. You can download this through this link, and after downloading it, we should follow the installation procedure. It is different for Mac users and it is for Windows users. For Windows user, they must have Java runtime environment and it can be downloaded freely from any of the sites. And after extracting the files, it will contain two folders. Here we'll get two folders. One is a project folder and the another is a tools folder. In projects folder, there will be different projects to be done in this course. And the tools will contain all the tools required to make the operating system or the hack computer. Later, we are also going to do a Jack compiler. So in this, using these tools, we can perform these different actions and use these simulators and stuff. So the project one overview is we'll be given a NAND gate, which is a universal gate, and we need to build 15 gates using hardware description language. The gates to be built are NOT, and or XOR, mux, demux, not which is 16-bit, and with 16-bit, or 16-bit, mux of 16-bit, or 8-way. It means it will contain, it's like a unary operator. It should have OR of it itself in the input itself, and mux of 4-way in 16-bit, mux of 8-way in 16-bit, demux of 4-way, and demux of 8-way. Now, we must write the hardware description language or description codes in the in of all these gates using NAND gate, and after one by one we can use the previous gates and be used in the new gates. So we have these tools called hardware simulator. In this hardware simulator, we can work with these tools. Yeah. So after this gets open, we can uh, write those codes and execute and try to check what will happen here. So as mentioned, we need to perform these gates, the codes, and then hardware simulation options. There are two types of simulation options. One is the interactive mode, one is a script-based mode. In interactive mode, user can give their desired input, and check the input using evaluated option on the menu bar. This is the menu bar here. This is the menu bar, and here this is the evaluate option calculator. It looks like a similar calculator button. And then after loading the code, we can press this evaluate button, and then the output can be shown in this window. This is the input pins window, this is output pins window, and here we can see the code. So, and in the script-based mode, test script can be loaded, and it contains a sequence of commands, and it is directly executed when it is run, and it is kind of automating testing and replicable testing. We can load the script with this button. We can find this test script button here. So pressing it, we can load the test scripts and perform the actions. So first is a not chip. According to truth table, we know that if a given input is 0, the output will be 1, and if the given input is 1, the output will be 0. So for this HTL code will be, these are the ports in which NOT gate will be used. It's an input port, and this output port. And using NAND gate, we should implement. So in this way, if NAND gate is, if both are given the same input, it will perform an AND operation, and it will give the inverse of it. So we'll get a NOT gate. In a similar way, for AND gate, is the truth table. If we give 0 and 0 as input, we should get 0, 0 and 1, 0, and 1 and 0, 0, and 1 and 1, we should get 1. So this is the HTL code for AND gate. We used an AND gate to give the output, and then we are applying a NOT operation to get the AND gate. Similarly, for all, we use um, two NAND gates in first to make A into not A and B into not B. And again, we are adding to a new NAND gate to get the OR. Here we use the De Morgan's law to classify this operation. And for XOR, this is the diagram and this is the truth table. And in the similar way, we write the HDL codes for all the 15 chips mentioned earlier. And finally, if we get into the simulation, we can run the above codes using the hardware simulator, which we find here. So as we mentioned earlier, this can be tested using interactive mode or script-based mode. So this is the load chip operation. Using this one, we can load the chip, and every time here it can be edited. Every time we must edit the file using notepad or some text editor, and then load into this hardware simulator. So after loading this, we can find different windows opened here. This is the input pins folder window, and this output pins window. This is HTL language code, and some internal pins if we have used, like and A and B has been used here to as a wire, as used as a wire. So this can be used as part pins or input pins, internal part pins. And yes, so we can modify our values in the here. So changing A to 1 and B to 1, we should get as out as 0, and this is the evaluate button to be pressed in the interactive mode. Yes, and we get the output value as 1. And another way of executing this is test script file. So we have a script file here. Okay, so this is already having the sequence of course. We no need to load anything or stuff. It is already mentioned load and file, and we will get output file where the output of this code will be mentioned there. And there is already a compare file mentioned in projects folder. The first project, we have different types of files mentioned here. This is a compare file which will contain the output given by the Nand Tetris application. This is the required or desired output to be found out. And after writing our HTML code, and when we after writing our HTML code, when we run and get our output through the script-based mode, then we can find this out, get and out or according their corresponding out files here. And so if we this button is a single step button, so until it finds a semicolon, it will run till there. And this is a full run button. So it will run until the file gets completed. Yeah. So in the similar way, we can find this is the view option script. This is the script view. This output view. The output found, the output which is found here, we can get here. So this is a reset button. Pressing this reset button, the program will start again. So let's press the run button again. So pressing the run button again, you can see the animating thing, like it will process one by one and we can get the output. And in the similar way, we can load some other chip. Yeah. So after load, this is a MUX 4-way in a 16-bit chip. So in this way, after running this let's go to the output mode. Yeah. So in the output mode, after running, we can get output line by line. And this format is in decimal mode. We can change into binary mode and we can see what's the desired output. Yeah. So these are the ABCD values and cell values. This is the output which we get. Yeah. So in a similar way, if we go to the other file, loading the script, uh, these all are the test cases. We can say this as a test cases. This set command sets the value. Like we need not set here separately or each bit in the code itself is mentioned here. So it directly sets into this input pins and we get the desired output in the output file. In compare file, okay, let's run this output. Yeah. So in the one by one way we get output. Yeah. So in this way we'll run all the script and we can get all the outputs, the output format. We can check it with the compare one. If both are identical, then our code is working fine. If not, we should change our code and write a correct code. Then this way we can use the hardware simulator, and these all are the components or options we can use in the hardware simulator for project one. So thank you.